So, have you ever built a data science model that, well, it worked, but you just had that feeling that it could be better? It was good, but it wasn't great. Today, we're going to close that gap. We're going to dive into the techniques that take a model from just functional to truly exceptional, leveling up your skills from a home cook to a master chef. This quote right here, it nails exactly what we're talking about. See, it's not about just blindly following the steps in some tutorial. It's about really truly understanding your ingredients, your data, and your techniques so you can start to improvise, to refine, and to create something that's genuinely remarkable. It's all about mastering the craft.
All right, so to really get our heads around this, let's frame it as a journey. We're all on this path from being a home cook in the data science kitchen to becoming a master chef. And believe me, that shift in mindset is absolutely everything.
So, on one side, you've got the home cook. They're following the recipe, doing some basic model training, and getting pretty good results. And hey, that's totally fine. But on the other side, you have the professional, the restaurant-grade chef. They are perfecting that recipe, using advanced tuning and selection, and getting those exceptional, jaw-dropping results. That's where we're headed today.
Okay, so what's the first secret ingredient we need to learn? It's a little something called hyperparameter tuning. And honestly, the best way to think about this is like learning how to season your food perfectly. It's that final touch that takes a dish from bland and forgettable to a flavorful masterpiece. It's what takes a good model and makes it a truly great one.
So what exactly are these knobs and dials? Well, put simply, they're the settings that we get to control before the model even sees a single piece of data. They're like the rules of the game we set up in advance. They control things like how complex the model can get, how fast it should learn, and ultimately how well it's going to perform.
So how in the world do you find that perfect combination of settings? Well, there are three main ways to go about it. You've got grid search, which is the brute force method. It literally tries every single combination you can think of. It's thorough, but man, it can be painfully slow. Then there's random search, which is a bit smarter. It tests random combinations and often stumbles upon a fantastic solution way faster. And finally, you have Bayesian Optimization, which is the really sophisticated one. It actually learns from each try to make smarter guesses about where to look next. But you want to know a secret? For most projects, random search is an awesome and super efficient place to start. But listen up, because this is the crucial part. No matter which tuning method you use, you absolutely, positively must use cross-validation. Think of it like this. You wouldn't taste test a giant pot of soup by just taking a spoonful from the very top, right? You'd stir it and taste from different spots. That's what cross-validation does. It makes sure your model's performance is the real deal and not just a lucky fluke on one slice of your data. All right, our next technique feels a little backwards at first. We're going to talk about the idea that sometimes less is actually more. This is feature selection, the art of intentionally taking ingredients out to make the final result even better. It's such a tempting thought, isn't it? More features, more information, that's gotta mean a better model, right? Well, surprisingly, the answer is very often a big fat no. And this leads us straight into one of the classic traps in data science, something called the curse of dimensionality. Let me break it down. When you throw too many features, too many ingredients into the mix, your model just gets confused. It has so much to look at that it starts seeing patterns in random noise instead of the real important signal you actually care about. What you end up with is a model that looks like a genius on your training data, but then completely falls on its face when it has to deal with new data from the real world. So how do we declutter this workspace? Well, first, you can find features that are basically telling you the exact same story and just get rid of the duplicates. Second, you can use proper statistical tests to actually prove which features have a real, meaningful connection to the thing you're trying to predict. And a third, really cool way is to just train a simple, quick model and let it tell you which features it found the most useful. Let the model do the hard work for you. And the payoff for doing this? Oh, it's huge. The difference is like night and day. By trimming down from, say, over 100 features to just the 15 most powerful ones, your model gets faster, it's way easier to explain to people, and very often, it actually becomes more accurate and reliable. It's a total win-win-win. Okay, now we're getting to the really fun stuff, the secret sauces. We're talking about advanced kitchen techniques, those pre-processing steps that take a model that's 90% of the way there and push it to 99% production ready. This is where the real mastery shines through.
So let's take a classic problem like detecting credit card fraud. The thing is, fraudulent transactions are super rare, maybe less than 1% of all the data. So a lazy model could just predict not fraud every single time.
and get a 99% accuracy score. Sounds great, right? Except it's completely useless because it fails at the one thing we built it to do.
So how do we fix this? Well, we have to rebalance our ingredients. We could use less of that super common not fraud data, or we could create more fake but realistic examples of the rare fraud data to balance things out. But a really elegant way to do it is to just tell the model, hey, a mistake on a fraud case is 1,000 times worse than a mistake on a normal one, so you better pay close attention to it.
Now here's another pro-level technique, Principal Component Analysis, or PCA. Now you might be thinking, wait, didn't we just talk about getting rid of features? Well, this is different. With PCA, we're not just picking the best ingredients. We're actually combining lots of them to create a brand new, super concentrated flavor. It's like simmering down a bunch of vegetables for hours and hours to create this rich stock that has the essential flavor of everything. PCA does that for your data, distilling all that important information down into just a few powerful new features.
All right, deep breath. After all that careful tuning, selecting, and advanced prep, it is the moment of truth. It's time to serve our creation and use our perfected model to make predictions on brand new, real-world data it has never seen before.
And right here, I need you to listen very carefully. This is a point that trips up so many people. Any new data that comes in has to go through the exact same prep pipeline. I mean, every single step. How you handled missing values, how you scaled your numbers, all of it has to be perfectly identical to what you did on your training data. Consistency here is it's absolutely non-negotiable.
You want to know what really separates the seasoned pros from the rookies? It's this. A truly great data scientist, just like an honest chef, knows the limits of their creation. If a totally new type of data comes along that the model has never seen before, the most responsible and professional answer you can give is to flag that uncertainty, to say, I don't know, instead of just blindly making a guess. So when you look at all of this, you can see it's a journey with some really clear stages. You start out just following recipes, right? Running tutorials. Then you get comfortable enough to start tweaking those recipes for your own projects. Before you know it, you're creating brand new recipes from scratch to solve new problems. All the techniques we've talked about today are designed to get you moving confidently from stage 1 to stage 2 and way, way beyond.
So after all that, what's the one thing I want you to take away from this? It's this. Every technique, every cool algorithm, everything we've talked about, they're just tools in your kitchen. They're powerful for sure, but they are not the point. The point is to use these tools to solve interesting, meaningful, real-world problems. So go on, step into the kitchen. The world has plenty of problems that are waiting to be solved.